Okay, hello and welcome to lesson 56. Today we're going to talk about finite and infinite sets, among other things. So to begin with these sets, we can either have sets that are finite, which means they have an ending, or infinite, which means they don't have an ending. So in this case here, we have the first set is a finite set because there are no other numbers, it stops there. The other set is infinite because it keeps going forever and ever and ever. It is also defined as something you could never possibly count because you can't possibly go this far. It's impossible to count that long. You would be counting forever. But that's pretty simple. Let's go to the next part. Membership in a set. So if we have all these numbers right here, we've got a bunch of zeros, a bunch of ones, a bunch of twos, and we want to put those in a set labeled set B. We're going to write B equals, and then draw our set. 0, 1, 2. So even though there are 6 zeros, 3 ones, and 4 twos, that doesn't matter. We're only going to write each number once. So it makes it really easy. So our set B just consists of 0, 1, 2, and that there is a finite set. For set K, if I wanted to make this here, we would have 0, 1, 2, 4, 5, and 7. Notice again, I only listed each of them once. And the order doesn't matter here. I know we like our ABC order, we like our numerical order. This one, it does not matter what order you put the numbers in, but I just put it in numerical order just because it looks the nicest. So the next part you need to know about sets is that we use these two symbols. The first one means is a member of. The second means is not a member of. So in this case, 1 is a member of the set K. You can see here, if 1 I can locate in my set. It does exist inside of the set. For the second one, the number 6 is not a member of the set K. If I look through set K, I don't see the number 6 anywhere. Therefore, 6 is not a member of set K. Okay, for the third part of lesson 56, we need to talk about rearranging before graphing. So this was on one of our worksheets. It got us really confused. Let's just walk through it. So we're going to take this equation right here, 3x plus 2y equals 4, and try to rearrange it to get that y alone, because we want to put it in slope-intercept form. If you remember that, it's y equals mx plus b. That's the form we want it in. So we need to set the whole thing equal to y so that we can graph this. So I need to get that y alone. It's already on the left, which is where we want it, but there's something else in our way. The x is on the left too. So let's get rid of that 3x that's on that side by subtracting it, because they had added it, so we're going to subtract it. So we subtract 3x from this side, and let's subtract it from the other side too. Now let me rewrite our problem really quick. Now we have 2y equals 4 minus 3x. Okay, that's getting us kind of towards y equals mx plus b, but we still have something in the way of our y. We still have a 2 there. So to get rid of that 2, we just divide by 2. So we divide by 2 to cancel those out, and then we're going to divide by 2 on the whole other side. We have to make sure we get it inside of every other term, so we have to divide by 2 on the whole side. Now if I rewrite that again, now I have y equals 4 minus 3x completely divided by 2. But that's not the prettiest. That's not really in the format that we want. So I'm going to rewrite it again. But this time I'm going to divide each term by 2. So if I divide the first term, 4 by 2, 4 divided by 2 is just 2. You can hear my cat running around. He's going crazy. Okay, and the second term, 3x. If I divide that one by 2, I'll have minus 3 over 2x. So now we have a fraction. I know you guys hate fractions, but this is so much prettier than the way it was before. And I can just rearrange this one more time to actually put it in y equals mx plus b. So we need the term with the x first. It would be y equals negative 3 over 2x plus 2. Because that 2 here is positive. So we're going to add 2 here. And then this would be our final answer. Now, you could keep it in something like this or this. As long as the y is alone, you are technically okay. You would still be able to plug it into something like this and solve for x, but it would, solve for y, but it just looks so much prettier the other way, and we want it to be in y equals mx plus b for later lessons, so I suggest you get in the habit of putting it into that form. But technically, if you wanted to leave it like those other two ways, not completely in the right format with just the y alone, that would be okay too. But we're gonna keep it like this, the way that we solved for it, and now we're gonna plug some numbers in so that we can graph it over here. So we have y equals negative 3 over 2x plus 2. Now in the book, they already gave us some numbers for x. They picked some terms. They're not the same as the terms that I pick usually, but they're pretty close. So they want us to plug in 0, 2, and negative 2 for x. These are our x's. And we're gonna plug in 3 different times. So let me write this out 3 different times, plugging in those numbers. So y equals negative 3 over 2, let's do the 0 first, times 0 plus 2. And let's solve. Y equals 0 plus 2, because 3 over 2 times 0 is just 0. So y equals 2 when x is 0. Okay, that's our first point. Now let me try it again, but this time I'm going to plug in the 2. Y equals negative 3 over 2 times 2 plus 2. Okay, so y equals negative 6 over 2 plus 2. Negative 6 over 2 is the same as negative 3. So now negative 3 plus 2 is just negative 1. So that is my answer when x is 2. Now one last time, and this time I'm going to plug in negative 2. Y equals negative 3 over 2 times negative 2 plus 2. Notice how each time I'm using that formula that I solved for. When I do negative 3 over 2 times negative 2, I get 6 over 2, which is also just 3. 6 divided by 2 is 3, plus 2. So y equals 5. Okay, so I finished my chart, and now I can use these as 3 different ordered pairs and put them on my graph. 0, 2 is right here. That is this one. 2, negative 1 is right there. Notice I'm doing my x-axis first, and then my y. So here's that one, second term. And then we have negative 2, 5, which is about there. Beautiful. So we have a nice decreasing line. It's sloping downwards. And my line, I'm going to try to make it as straight as possible. It goes like that. And it goes on forever and ever and ever. Perfect. So that is how you would graph that. So practice problem A. Represent the following numbers as being members of set K. These are our numbers right here. All we're going to do is place them inside the brackets and only list each number once. I'm going to put it in numerical order just because that's how I like it. So we have zeros, we have 1, 3, 5, 9. Now, I don't need to write 2 5s and I don't need to write 2 zeros, even though they're there, it doesn't matter. This is our set K. That would be your final answer there. For B, given the sets A, B, and C, are the following statements true or false? Okay, so we want to know if 5 is a member of the set B. So let's go to set B. And is 5 there? Yes, it is. So that one would be true. Question B, is 5 is not a member of the group C. Let's see if that's correct. We go to group C. Is 5 not a member of it? Correct. 5 does not exist there in group C, so that would be true. Oh no, there we go. For question C, they say 0 is a member of group A. Is that true? Go to group A. 0 is a member, so that would be true. For the last one, 3 is not a member of group C. If I go to group C, I do see 3 there. So that would be false because 3 is a member of group C, not 3 is not a member. So the last one is false. Okay, question C. Graph the following equation on a rectangular coordinate system. So we have 2x minus 3y equals 6. The first thing we have to do is solve for that y. We can't leave it like this. We have to make sure it's y equals something, preferably mx plus b in that format. But as long as it's just the y on the left, then we're all set. So let's solve for that y. The thing in our way is this 2x. We gotta get rid of that. So I'm gonna subtract 2x from over here and subtract it from over here, because anything I do to one side of the equation, I have to do to the other side. Then let me rewrite that. Don't forget this negative here. So it'll be negative 3y equals 6 minus 2x. Let's keep solving. Now the thing in the way of our y is that negative 3. Let me divide that out. Because negative 3 times y, the opposite would be divided by negative 3. Cancel that out. Divide this whole side by negative 3. So then I have y equals 6 over negative 3 minus 2x over negative 3. Now I immediately see this double negative here, and I would just get rid of both of them, make it all positive. Makes it a lot easier to deal with. So we have y equals 6 divided by negative 3 would be negative 2 plus 2/3 x. That would be our final answer. Our y is alone, everything else is nice and simplified. Now we're going to use that equation and plug it into this table so that we can graph it. They gave us the x's. All we have to do is plug in these values for x. So first, if I plug in 0 for x, I have y equals negative 2 plus 2/3 times 0. That's a really easy one to solve because 2/3 times 0 is just 0. So I'm left with y equals negative 2. That would be my answer for the first one. Now if I plug in 2 for x, I have y equals negative 2 plus 2/3 times 2. So y equals negative 2 plus 4/3. Now, I'm going to have to find a common denominator. I'll make the denominator over here 3, which means I had to multiply that negative 2 times 3, which would make that a negative 6. So negative 6 plus 4 is negative 2. So my answer is y equals negative 2/3. That's going to be kind of ugly to graph, but we can do it. We can manage it. The next one we have to plug in is negative 2 as x. So we have y equals negative 2 plus 2/3 times negative 2. So that would be y equals negative 2 plus negative 4/3. We have to find a common denominator again. Let's make that the same as before. A nice negative 6/3 plus negative 4/3. So that would be y equals negative 6 minus 4 is negative 10 over 3. Which is equivalent to negative 3 1/3. Okay, so now we have to plot these points. So my first term would be 0, negative 2. I'm going to start at 0 on the x and go down negative 2 on the y. So I end up right there. For my second term, 2, negative 2/3. I'm going to go on my x to the 2 and then down 2/3. So it'll be right before the negative 1. And that's where I'll land, right about on that number. And for my third term, negative 2, negative 3 1/3. I start at the negative 2 on the x and I go down to negative 3 1/3, a little bit past the negative 3. So it'll be right about there. That would be my third term. And I have a nice increasing slope here. It's a positive slope. And it's a little bit under that x-axis. It goes like that. It's not the straightest line ever, but you get the point. That would be the answer to question C.